Happy morning to one and all person here. Today I would like to share the new topic about the thin cylinder. A thin cylinder is a pressure vessels used to store liquid or a gas under the pressure. It is called as a thin because of the wall thickness is very small compared to the diameter of the cylinder. For examples, we have a classified in a thin cylinders. So based on these diameters, we can be enhance the wall thickness. So it may be a, like example like including steam boilers, gas storage tanks, water pipes, air compressor tanks. So the thin cylinders are important in the mechanical as well as the civil, chemical and aerospace engineering. Then how the condition for the thin cylinder means we can justify the terminology. Capital D, diameter by thickness, it's a greater than of 20. So D is nothing but inside the diameters, and T is nothing but the wall thickness. Because of the thickness is small, the stress distributions is assumed uniform. For example, it can be a UDL platform. The stress is wall thickness is very less, and the radial stress is neglected because the assumptions made by the thin cylinder concept. And what are the assumptions to be made in the thin cylinders theories are the cylinder is well in thick, and material is homogeneous under the isentropic properties, and the internal pressure is uniformly distributed. Stress across thickness is constant. Cylinder retains circular shape after the loading. Ends are properly closed. Deformation is very small. And how the stress developed in the thin cylinders means the stress is nothing but how much we can load act on the particular body, how it can be withstand. So it's nothing but a load by area. But the hoop stress, sometimes called as in the circumferential stress, the stress acts tangentially around in the circumference. It tries to split into the cylinders along with the length. How can we calculate for the hoop stress means PD divided by 2T. Internal pressure diameter divided by the twice of the thickness. Then next one we can be calculated with the help of longitudinal stress. After we go with the hoop stress, the stress is acts according to the axis to the length to the cylinders. It tends to split into the cylinder across the transversation of the sections. How can be calculated means instead of 2T we can multiply by the 4 times of thickness. So internal pressure and diameter divided by the 4 times of wall thickness. Hoop stress is twice the longitudinal stress. We can easily calculate it. And how the deformations in thin cylinders according to the pressure cases, increasing the diameter and increasing the length and increasing the volume. So it can be del D, del L and del V. So circumferential strength is equal to 1 by Young's modulus into hoop stress in minus mu into CS stress or a longitudinal stress. In the latitudinal strain, we can calculating the help of Poisson ratio along with the Young's modulus. Young's modulus is nothing but the stress by strain. And how we can calculating the change in volume for the particular thin cylinder means del V divided by V is equal to 2 Young's modulus plus the E1. So dV is nothing but a change in volume, and normal V means the original volume. Next we can go with the applications of thin cylinders. So in the mechanical or in a civil or in an aerospace, whatever the constraints we are having, but how the application to be made at particular area. For example, the steam boiler means used to store the steam at high pressure and high temperature in the thermal power plants. Like what kind of functions they are done means steam generation, pressure contaminations and heat transfer. Next one, water supplying the pipelines. So flow through venturi meter, orifice meter, likewise the municipal pipelines carry the water under the pressure over along the distance. What are the advantages we are getting the water supply pipeline means low material cost, easy installations and good flow capabilities. And the third one, LPGs and gas cylinders used for storing the compressed gas such as LPG, oxygen, nitrogen and CNG gases. And the next area is nothing but the air compressor tanks. It can be stored compressed air in the industries as well as the workshops. So what kind of uses we can be carried out, like pneumatic tools, spray paintings, and automatic systems, and the final one applications is nothing but the hydraulic cylinders. It can be contained pressurized hydraulic fluid in terms of cranes or accelerators or pressure machines. So these are all the very important things which can be covered for the thin cylinders. Thank you all.